Dear students, in this video you will be learning about how to solve LPP formulation using graphical method. So this is Dr. M. Subbarao, Assistant Professor, Department of Mechanical Engineering. So the graphical method is a visual approach used to solve linear programming problem involving two decision variables. It helps identify the feasible region and optimal solution by the graphing the constraints and evaluating the objective function. So here this is the key steps involved in a graphical method. So first we need to formulate the problem, define the decision variable, objective function and constraints, and plot the constraints, convert the inequalities into equalities and plot them on graph, identify the feasible region where all constraints are satisfied, determine the corner points of the feasible region and find the points of the intersection of the constraints lines, evaluate the objective functions and compute the value of the objective function at each corner point, identify the optimal solution, choosing the point that maximizes or minimizes the objective function depending on the problem. So let us see, take one the problem and then we will see all these key steps in solving the LPP by using a graphical method. So let us see what are the graphical representations. So it also represents the feasible region, the area where all constraints overlap are called as feasible region, and corner points are the vertices of the feasible region, and objective function line, a line representing the objective function is the drawn and moved parallelly to find the optimal solution. So here in this method the advantages are it provides a visual understanding of the problem because we draw the solution in the graphical representation. So when you see the graph we will immediately understand the problem and the solution. Simplify solutions for problems with the two variables, the easy to interpret the results. So limitations here is applicable only when there are two decision variables and becomes impractical for problems with more than two variables and requires precision in plotting and calculations. So let us take one problem and try to solve by using this graphical method. So this is one problem. Solve the below LPP problem, a linear programming problem using graphical method. Find the maximum value of z, that is equal to 5x plus 7y subjected to the constraints. So here these are the three equations are given and with the objective function z is equal to 5x plus 7y. So we in the previous video we understand how to formulate the LPP. There after you understand the problem and write the linear programming, so you will get the set of equations. These set of equations we can solve by using two methods. One is graphical method and another one is a simplex method. By using this graphical method, how to solve? So here let us try to assume that these are the set of these are the set of equations you got from LPP formulation. Now let us try to see how to solve these equations by graphical method. So first of all, there are the key 5 steps involved. First, you take the graph, or otherwise you assume there is a x-axis and y-axis because there is x and y two decision variables are here. So this decision variable, let us say x is the first x-axis and y is on a y-axis, and this is the first quadrant we will be considering. So identify the intersection points of the lines because there are the three equations are given. For each equation is the line. Each equation is a line. So these lines we need to plot on the graph. So to plot these equations in the graph, we need to identify the intersection points of the lines and intersection point on the axis, so that it will be very easy to draw a straight line, because when you know 2 points, so when you know 2 points you can easily able to draw a line, infinite line. So here the x plus y is less than or equal to 4, and this for time being, in order to draw the line we are considering that is equal to 4, x plus y is equal to 4. So in x plus y is equal to 4, if x is equal to 0, and what will be the y? Y will be the 4. So the line is passing through 0 comma 4. So here it is passing through the point which is 0 comma 4. And again, if it is intersecting somewhere in a x-axis, on x-axis, so the y will be 0 there. So if y is equal to 0, x will become 4 comma 4. So the point which is this line is passing is 4 comma 0. So that means this x plus y is equal to 4 is a straight line which is passing through these 2 points. One is 0 comma 4, that is the 0, x-axis is 0 and y-axis is 4. So this is the point. And another point is 4 comma 0, on x-axis it is the 4 and y-axis is 0. So this is the point. So we will draw a line passing through these 2 points, and this line is less than or equal to 4. So the less than or equal to 4. So if you in the likewise, so there are 2 more equations. If you get the points where the equation is intersecting the x and y axis, so for 3x plus 8y is less than or equal to 24, for this it is passing through a point 0 comma 3 and 8 comma 0. And the another the equation 10x plus 7y is less than or equal to 35 is passing through a point that is 0 comma 5 and 3.5 comma 0. So these 2 points it is passing through. So these all graphs I need to plot on the graph, these lines I need to plot on the graph. So if I plot these lines on the graph, so this represents the first equation, that is x plus y is less than or equal to 4, and this is the first equation, and it is showing that x plus y is less than or equal to 4. That means whenever it is said it should be less than or equal to 4, less than, that will cover the area which is below to this line. So we are towards the origin. So when the graph is coming, the line area whichever is towards the origin, that area will cover the area which is less than symbol. So if suppose if x plus y is greater than 4, that will cover the above area which is away from origin, and x plus y is less than or equal to 4, this will cover the area which is the near to origin. So this area it will cover. So for this first equation, and a second equation, that is this that is passing through 0 comma 3 and another point is 8 comma 0. So I draw a line which is passing through these 2 points, and it is this area is near to origin because it is less than or equal to 24, and this area it is covering, so it is near to origin. So this first equation is covering this area, and second equation is covering this area, and third equation is this, that is 10x plus 7y is less than or equal to 35, which is covering the area which is this side, which is near to origin. So now we need to identify the feasible region. What is the feasible region? The feasible region is the area which covered by all the equations. So now in the objective in the constraints itself, it is giving these 3 equations, and also x is greater than 0 and y also greater than 0. That means it covers only first quadrant. It covers only in first quadrant, and second, the third, fourth equation, first, second, third equations covers the area which is in this region. So that means the feasible region is in this area. So if I draw a feasible region which is covering this area, so this is the area which is covering the feasible region. So now the next point, now as a first the point, we are identify the intersection points of the lines on the quadrants, and then what we did, we identify the feasible region which covered by all the equations. So this is the feasible region or common region which is covered by all the equation, all the constraints, and then we need to identify the next point is we need to identify the corner points of the feasible region. we need to identify the corner points of the feasible region. So these are the corner points of the feasible region. So that the first point is this 0, the point 1 is the 0 comma 0, and the second point is this where it is intersecting at 0 comma 3. So this is the second point, and third point is this, fourth point is this, and fifth point is this, and these are the 5 corner points of the feasible region. So I need to, as a second point, I need to identify the corner points of the feasible region. So I identified 2 points, and this is the third point. If I want to get the third point, because it is not intersecting x or y, so I need to identify, in order to identify this corner point, I need to see the intersection point of equation 1. This is the equation 1 and this is the equation 2. So intersection point of equation 1 and 2, if I see, that point is the third point. And then if I want to do that, so I will take these two equation. Equation 1 is this, x plus y is equal to 4. Equation 2 is 3x plus 8y is equal to 24. If I solve these two equation by substituting equation 1 into equation 2, in equation 1 x plus y is equal to 4. So from this x will become x is equal to 4 minus y. So that x value, x is equal to 4 minus y, you substitute in this equation, then it will become 3 into x is 4 minus y plus 8y is equal to 24. So here you have only y in the left side, on the right side you have value. So you will get here 3 into 4, 12 minus 3y plus 8y. Minus 3y plus 8y, so it will become 5y, that is equal to 24 minus 12. So that, because this 12, if it comes this side, 24 minus 12, it becomes a 12. Then y value will become 12 by 5. So you substitute this y value in this equation, x plus 12 by 5 is equal to 4, then you will get x value is equal to 8 by 5. So now the another corner point of the feasible region here is x comma y, that means 8 by 5 comma 12 by 5 is the point 3. So the point 3 is this, and now I need to get the point 4. The point 4 I will get it by so here this is the first equation. So this is the first equation it is going through, and this is the third equation, which is this point 4 is the intersection point of equation 1 and 3. Equation 1 and 3. So if I solve this equation 1 and 3 intersection point, then I will get this point, that will become the fourth point. So here now let me take these two equations, that is the first equation, and the third equation is 10x plus 7y is equal to 35. Now again I will substitute the y value in equation 3, that is equal to 10 into 4 minus y plus 7y is equal to 35. So here minus 10y plus 7y, it becomes minus 3y, and this 40 it is goes that side, it becomes minus 5. So now finally y value will become y is equal to 5 by 3, and substitute this y value in this equation 1. So you will get the x value, that is 7 by 3. So now this is the point, the fourth point, so which is x comma y, that is 7 by 3 comma 5 by 3. So that is the fourth point. So now this is the fourth point, 7 by 3 comma 5 by 3, and the next point is this point we already know, this is a 3.5 comma 0, because it is intersecting the axis. Thus the third equation is intersecting the axis at 3.5 comma 0. So these are the 5 points, are the corner points of the feasible region. So once after you get these 5 points of the 5 corner points of the feasible region, and on which point the value z is maximum, we need to identify. Now substitute the corner points of the feasible region into objective function. That is the next step, substituting the corner points of the feasible region into objective function. So now point 1 is 0 comma 0, Now you substitute this x comma y value. So x is 0 and y also 0. These two x comma y values in the objective function. So the objective function z is equal to 5x plus 7y. So in this if you substitute 0 comma 0, it will become 0. And now the point 2 you substitute in z. The point 2, this is 0 comma 3. So that if you substitute 55 into 0 plus 7 into y is a 3, so it becomes a 21. So then the point 3 is a 8 by 5 comma 12 by 5. If you substitute in place of x and y these two values, you will get z value is a 24.8. And point 4, if you substitute, z value will come 23.33. And 0.5, if you substitute, z value will come as 18.5. Now among this, our main objective is to maximize the z value. So among these all solutions of z value, which one is maximum, that we need to see. If it is a minimization problem, we need to see the minimum, but now it is the maximization problem, so we need to see which value is maximum. So here 24.8 is the maximum value. So the z is maximum at 0.3. So x value at 0.3 is 8 by 5 and y value at 0.3 is the 12 by 5. So finally x and y values we got it. So this is the solution. This is the solution for the given LPP. So likewise we need to solve the problems. So let us try to solve one more problem, similar problem. So then we will understand. So this is the first one, is the maximization problem. So where if they give a problem, so we need to maximize the profit. Z is we need to maximize. So let us take one more problem. So this is the another problem. So solve the below LPP using graphical method. Minimize z value. So here we need to minimize the z value. So z is equal to 3x1 plus 2x2. So here instead of giving x and y, they given x1 and x2. So this is also similar, but only thing is we will consider that x1 is on x-axis and x2 is on y-axis. Subjected to the 5x1 plus x2 is greater than 10 and x1 plus x2 is greater than or equal to 6, x plus 4x2 is greater than 12 and x1 comma x2 is greater than 0. So these are the three equations they given and the z they given, and here only difference is z we need to minimize. That is the difference here. Z we need to minimize. So if you take these all equations, and first what is the solution, what is the first step, we need to identify the intersection point. So here where it is intersecting, you need to see x, we need to take x1 is equal to 0, then you will get it x2 as the 10. So then the point will become the 0 comma 10, and x2 you need to, x1 you need to, the x2 you need to consider 0 and you need to get the x1. So then x2 will become a 2 comma the 0. So these are the 2 points which is passing through. And likewise, if you take for each and every the equation, the values, the x1 and x2 values, and where it is intersecting the x-axis and y-axis, so you will be, if you draw it, the equation will be like this. So the first equation, the 5x1 plus x2 is less than or equal to, greater than or equal to 10. So this is the equation, this is the line, the first line is the first equation represents this line. So here the x1, 5x1 plus x2 is greater than or equal to 10. So when it is greater than, so value should be the greater than, that means the area which covers should be away from origin. So this is the origin, so it should be away from the origin, other side of the line. So this is the line, this side origin is there. When it is greater than or equal to, it should be away, other side of the origin. So now that means this line, the 5x1 plus x2 is greater than or equal to 10, the covers the area which is this side, but where it will end, it will go like this with the infinity distance. But this is the line which is the minimum area which is starting from here. Then the second equation, if you take, that is x1 plus x2 is greater than or equal to 6, This is the equation which is passing through these 2 points. So one is a 0 comma 6 and another one is 6 comma 0, and it is also greater than or equal to 6. So it will cover the area which is away from the origin. So this is the origin and away from the origin is this. Whenever greater than symbol is there, you need to take the area which is away from the origin. So this is the area which will be covering. Then the third equation, that is x1 plus 4x2 is greater than 12. So that is the area which is covering greater than away from origin, this area. So if you see the feasible region is the region where it covers the all combined area. So this is the combined area. So this is the feasible region. So now we need to identify the corner points of the feasible region. So this is the first corner point A. So A is the 0 comma 10, and second corner point is the B. So B is, if you need to see the intersection point of first equation and second equation, and if you see the intersection point, this will become 1 comma 5. 1 comma 5 is the another corner point, and if you see the another intersection point of this second equation and the third equation, that intersection point will be 4 comma 2. So, and again another corner point will be this 12 comma 0. And what are the other the corner points? Because this is covering the infinity area, so we can't identify the other infinity area points. So, but anyhow, we are going to get the value, minimum value. It is not the maximum value we need to get it. So, because the maximum value don't have a boundary. So that is why they given as a minimization problem. So we need to worry about the minimum values only, not the maximum. So any points above this area, infinity area, will be covering only a maximum, value only. So it will not be a minimum value. So we will be worrying about the minimum values, whether we will get the minimum value at A, B, C or D, we are going to see. So now we need to substitute these corner points. Now the corner points are only 4. These corner points we need to substitute in the Z, equation Z. If you substitute these corner points A, B, C, D values in a Z, Z is equal to 3x1 plus 2x2, and if you substitute A in this, the Z is equal to 3x, the x1 is equal to 0 and x2 is equal to 10, so it will become 20. And B, point B, 1 comma 5, if you substitute, it will become 1 into 3, so 3 plus 2 into 5, so 10, 10 plus 3, so 13. And then C, if you substitute 4 comma 2 and 3 into 4 plus 2 into 2, it will become 16. And D point 12 comma 0, if you substitute 3 into 12, 36 plus 0, 36. So out of this all Z value, because we need to minimize the Z, so which one is giving the minimum value? So the 13 is the minimum Z value at point B. So finally the X and Y values will be X is equal to 1 and Y is equal to 5. So this is the final solution. X value will be 1 and Y value will be 1, Y will be 5. That will give the optimum the solution for the given LPP. So that is how we can able to solve it. Let us solve one more problem. And graphical method, problem 3, solve the below LPP using graphical method. So maximize, again this is the maximize. Z is equal to 3x1 plus 4x2 subjected to 5x1 plus 4x2 is less than or equal to 200, and 3x1 plus 5x2 is less than or equal to 150, and the 5x1 plus 4x2 is greater than or equal to 100. 8x1 plus 4x2 is greater than or equal to 80. So these are the equations. There are two equations which are less than or equal to symbol, and two more equations are greater than or equal to some values. So at that time, whenever there is the less than or equal to, greater than or equal to, two different types of the equations, how to solve this problem. Even whether less than or equal to symbol or greater than or equal to symbol, we need to first see what is the whether we need to maximize or minimize the problem. That is the most important. And the second one is we need to plot these equations, and we need to identify the feasible region where the common boundary. So that we will do. So if you plot these all equations after finding the the corner points, where it is not corner points, sorry, the intersecting points on the x and y axis, the graph will be coming like this. So let us see, these are the equations, set of equations, and this is 8x1 plus 4x1 is greater than or equal to so this will cover the above region, and this is another equation, this covers the below region because it is less than or equal to 200, and this is the equation, it is also covering the less than or equal to the equation, and this is another equation which is also giving greater than or equal to 100. So that means these two equations are greater than symbol. That means it will be covering the away from the origin, but these two equations are given less than or equal to symbol, so it will be covering the below area. So finally combined area is this. This is the feasible region. So now we need to identify the corner points of the feasible region. Let us say this is the O, that is 20, 0, and this is the A, that is 40, 0, this is the B, 30.8, 11.5, and this is the C, 0, 30, and this is the D, 0, 25. These are the corner points. So if you take these all corner points, these are the O, A, B, C, D are the corner points of this feasible region. So now these feasible, now we need to see where we are going to get the maximum Z value. So for that we need to substitute each point in the objective function. So in the objective function, if you substitute each value, so we are going to get the Z value. So Z value, Z is equal to 3x1 plus 4x2. So if you substitute x1 and x2 values, and at O we are getting Z value as 60, at A we are getting a Z value as 120, at B we are getting Z value as 138.4, C we are getting 120, D we are getting 100. So if you identify all these the Z values, Z value is maximum at B, that is 30.8, 11.5. So feasible region is given by this. So finally the maximum value of Z is obtained at point B. So x1 value will be 30.8 and x2 value will be 11.5. So that is the final value of x1 and x2. So this is how we are going to solve the problem by using a graphical method. So let me conclude. So here the graphical method is a simple and effective way to solve LPP problem with two decision variable. It involves plotting the constraints as a straight line on a graph and identifying the feasible region that satisfy all constraints. The method helps to understand the geometric interpretation of linear inequalities and optimization. However, it is limited to the problems with only two variables and not suitable for higher dimensional problems. Thank you for listening.